This is tutorial 1, question 4. We are given a matrix A, and a matrix A has 3 rows by 3 columns, so it's a square matrix 3 by 3. And we have a column vector B, which is a 3 by 1. The question basically asks can B be constructed by A multiplied by X equals to B? Can this happen? The question went about roundaboutly. First it says, let us create a space called W, and W is spanned by A1, A2, and A3, and these A1, A2, A3 are the columns of A. So W is a space spanned by these 3 columns. What it means is that it is a set of all vectors that we can construct such that is summation of let's use xi ai instead. I equals to 1 to 3. So basically we have x1 times a1 plus x2 times a2 plus x3 times a3. Basically we're saying that let us find a set of vectors created by these linear combinations of these 3 columns where x are some scalar. And let's call this W, the span of the 3 column vectors. Now, how to answer is B in W? That means can B be found in W? In this case, we are going to use Gaussian eliminations to solve the problem. We put the matrix A, augment it with B, and we are going to solve. Remember that when you are solving the augmented matrix, you're asking yourself to find the x that will solve for this equation. And if x can be found such that the left hand side is equals to the right hand side, then what we are saying is that yes, B is in the column space of A, or B is in the span of W. Right, so we write the augmented matrix. This is A and this is B. We use the dotted line to separate the two. We perform elementary row operations. Let us just revise this elementary row operation. Here it says that this row R3 is equals to itself plus 2 times row 1. So row 1 is here. We multiply it by 2, and then we are going to add row 1 times 2 to row 3. This is the answer we found. You can go through it by yourself. We've ended with this equation after the row operations, and we have 3 pivots. Given that there are 3 equations, 3 unknowns, and all the 3 pivots can be found, then we can say that the equation is consistent. We can find the unknown variable x1, x2, x3 to solve for this equation, and hence B is in the column space of A. You can solve it by yourself using back substitution. So what we do is that we solve first for x3, and then substitute x3 into the second row to solve for x2, and then using x3 and x2 found, substitute into the first row to solve for x1. Please try it yourself. This is what we have found for x1, x2, x3. We put it into A such that we can multiply A by the found variable x1, x2, x3, and we found that the answer is exactly B. So this is just a sanity check to say that yes, B is in the column space of A using these variables found. In the second part of the question, it asks you how many vectors are there in W. Remember that the word span here means linear combinations of these 3 columns, means exactly this statement, linear combinations of A1, A2, A3. Now, x is any scalar, as in any real numbers in our course. So therefore, we can multiply by any number, and hence there are infinitely many vectors we can construct from these 3 given column vectors. Thank you.